For the past several weeks, we have been focusing on the rules of algebra, specifically the first three rules. Number one, the variable wants to be positively alone. Number two, what you do on one side of an equation, you have to do the same thing on the other. And number three, to get rid of a term, you're going to use opposite math. With the asterisk that if it's a division problem where the variable is on the bottom, then you actually use division to get rid of division, but most of the time, to get rid of something, you use opposite math. In applying these three rules, we have been focusing on one-step algebra problems, meaning that there's only one thing to get rid of in order to get the variable by itself. If you have x plus 2 equals 5, all you have to do is get rid of the plus 2, and you have your answer. Today, we're going to focus on two-step equations, and in order to do that, we need to introduce the fourth rule, which is, if you have to get rid of multiple things, you use the order of operations backwards. This also has an asterisk, and we'll mention it here in the next slide, but it's not going to be relevant for us for a couple of weeks. Okay, the order of operations. Let's review. A lot of people say the order of operations uses the acronym PEMDAS, and if you learn that and it works for you, that's great. In 6th grade, when we learned the order of operations, we learned a slightly different version. First, that you take care of anything inside parentheses or brackets. We call these groups. Then, you take care of any roots or exponents. After that, division and multiplication, and finally, addition and subtraction. The acronym that we used was GREDMAS, which takes into account that groups can use things besides parentheses, and whenever you're doing exponents, you also have to keep track of roots. Now, if we're going to use the order of operations backwards in order to do two-step algebra, let's look at what happens. Instead, we're going to start by getting rid of addition and subtraction. Then we're going to get rid of division and multiplication, and for now we'll say that the last thing we do is exponents and roots. That might change here and there depending on the problem, but again, we don't need to worry about that for a couple of weeks. Now, you may be wondering, what about groups? They didn't show up on this list. This is the part that has the asterisk, because you're actually still going to have to deal with the groups first. But we don't need to worry about that today. That'll be obvious when it comes up and becomes relevant. There isn't really a nice, easy acronym like PEMDAS or GREDMAS for this version. GASDMR just doesn't really roll off the tongue. Let's look at an example of a two-step problem. 2x plus 1 equals 7. Let's grab the pen here and see what we need to do. Let's put the various terms into boxes. That term is 2x, and the second term on this side is plus 1. Notice that the symbol in front of the final number goes into the box with it. Now, our goal, as always, is to get the variable by itself. We want the x all alone with nothing between it and the equal sign. In order to get that to happen, we're going to have to get rid of not one, but two things. We have to get rid of multiplication. We have to get rid of multiplied by 2. We also have to get rid of plus 1. There's two things happening to our variable right now. And so, in order to get rid of multiple things, we're going to use the order of operations backwards, meaning we have to get rid of addition or subtraction first. How do we get rid of the addition, plus 1? We use opposite math, which would be minus 1. And of course, whatever we do on one side, we have to do on the other side. Now, I like to draw a line underneath those steps, and then imagine what is happening in each box. Let's put a box around the 7 too. There is nothing below the 2x, so it comes straight down without changing. Plus 1 and minus 1 are opposites, so they blow up. They no longer exist. The equal sign is always there for us. It does not move. And we have 7 minus 1, which is 6. Now we have a two-step problem reduced by a step. We're down to one step, which is what we've been doing for the last few weeks. 2 multiplied by some number equals 6. We want to get this variable by itself, which means we have to get rid of the multiplied by 2. What's the opposite of multiplied by 2? Divided by 2. Whatever we do on one side, we have to do on the other. These blow up. The variable comes down. 6 divided by 2 is 3. Now, let's double check that our work is correct. We can do that by replacing the letter x with this number, because we've just discovered that the letter x is equal to 3. That means the letter x and 3 are the same thing for this problem, and they are interchangeable. Wherever we see an x, we can replace it with the number 3. So we're going to rewrite our problem as 2. We're going to replace the letter x, with a 3. Ignore this. And then we're going to add 1. And the answer should be 7. Let's see if that works. 2 multiplied by 3 is 6, plus 1 is 7. Voila! We got the question right. For this problem, x is equal to 3. Let's look at another example. Some number divided by 2 minus 3 equals 7. Let's put our boxes together first. We put a box around this division, another box around minus 3. Notice that the symbol in front of the 3 goes into the box with it, and then just for clarity's sake, a box around the 7. Okay, if we have to get rid of multiple things, we do the order of operations backwards. We have to get rid of divided by 2, and we have to get rid of minus 3. If we're doing the order of operation backwards, that means we get rid of addition and subtraction first. To get rid of minus 3, we're going to add 3. But we have to add 3 to both sides. Let's see what happens next. Put the line in. Nothing has changed in this box, so it comes down unchanged. Minus 3 and plus 3 blow each other up. Bring down our equal sign. 7 plus 3 is 10. Phase 2, we're down to a one-step problem. Same thing we've been doing for a couple of weeks now. We have some number divided by 2 equals 10. We need to get rid of divided by 2. The opposite of divided by 2 is times 2. What we do on one side, we have to do on the other side. These blow each other up because they're opposites. The x comes down all by itself. The equal sign is always there for us. 10 times 2 is 20. Let's check our work. Replace the letter x with a 20 and see if the math holds up. So the letter x is on top. 20 divided by 2 minus 3 equals 7. Does that work? Well, 20 divided by 2 is 10. Take away 3 is 7. Our answer is correct. For this problem, x is worth 2. All right, third example. It's another division problem, this time with addition attached to it. So, let's put our boxes in. X divided by 4 gets a box. Plus 2 gets a box. Notice the symbol in front of the number stays with it. And we'll put a box around the 8 just because. If we're going to use the order of operation backwards to blow things up, we have to get rid of addition or subtraction first. So we're going to get rid of plus 2 by doing minus 2. And do minus 2 on both sides. Draw my line underneath. Nothing has changed in this box, so it's going to come down without any changes. These guys blow each other up. The equal sign is always there for us. 8 minus 2 is 6. And now we're down to a one-step problem. The only thing that we have to get rid of is divided by 4. The opposite of divided by 4 is multiplied by 4. Got to do it on both sides. These guys blow each other up. The x comes down unchanged. Equal sign, 6 times 4 is 24. Check our work. If we replace the letter x with 24, what happens? 24 divided by 4 is 6. Add 2, you get 8. Our work is correct. All right. What about 3x minus 4 equals 11? Let's put our boxes. 3x gets a box. Minus 4 gets a box. Notice the minus sign stays with the 4. And just because, we'll put a box around 11. Order of operations backwards says that we need to get rid of the addition or subtraction first. So to get rid of minus 4, we're going to do plus 4. Got to do the same thing on both sides, so we have to add a plus 4 on the right as well. Underline, nothing has changed in this box. It gets to come down without any alterations. Minus 4 and plus 4 are opposites. They blow each other up. The equal sign is always there for us, and 11 plus 4 is 15. Now we've got a one-step problem. We know how to do those. Right now, our variable x is being multiplied by 3, and we get 15. How do we get rid of multiplied by 3? You divide by 3. But you've got to do the same thing on both sides. These blow each other up. The x comes down. It's now positively alone. 15 divided by 3 is 5. Check our work. Replace the letter x with a 5. 3 times 5 is 15. Minus 4 is 11. We are good to go. Your homework due before tomorrow morning when we have class is in your homework folder on OneNote. It is 13th of October, two-step equations worksheet number 1. I'll see you tomorrow morning.